morning, Geometry iPad Initiative students. This is Mr. Lane again, coming at you from OHS High School. This is Section 9.6, which is over geometric probability, which is going to be very similar to the probability sections that we just reviewed for the state assessments coming up. So make sure you get the title, make sure you answer number 5, make sure I get half a page of notes, and a summary to get full 5 points credit. Let's move on here. Geometric probability is probability of an event that is based off of a ratio of geometric measures such as a length or area. I've got some different types right down here of geometric probability. When we're talking about length, we're going to put the segment that we're trying to have happen, which would be BC in this section, over the entire length of the segment, which is AD. On this, we want the central angle over the 360 degrees, and then when we're talking about maybe a dartboard or something, we definitely want the shaded region over the entire dartboard itself. So might look over those real quick. We're going to move on here and look at the first example. We've got a point that's chosen at random from this length of PS. We're supposed to find the probability that the point is not on QR. Well, QR would be the 13, so what's outside of this 13 would be the 7 and the 5. So our favorable would be the 12 over the total, which would be 25, and that won't reduce, so the probability that it would not be on QR would be 12 over 25. Alright, another quick example right here is the point is on PQ or QR. So if I add those two together, I have a length of 20 over a total length of 25. That will reduce. Take a 5 out of both of those would be 4 out of 5. Bada boom, bada bang. I've got my probability of a point is on PQ or QR. So regular geometry students would be doing 2, 4, 16, and 18. iPad Initiative, yours is on the Lumen site. Alright, we got a signal at the crosswalk has the following cycle. It says walk for 45 seconds and don't walk for another 70 seconds. What is the probability that the signal will show walk when you arrive? Well, the favorable then would be the 45 seconds that it says walk. Not over the 70, but over the total when we add the two of 115. So if I take a 5 out of both those, I'd have a 9 over a, let's see, 2, and then a 15 would be a 3. So 9 over 23 probability that when we arrive it says walk. Let's move on here. If you arrive at a signal 40 times, predict about how many times that you will have to stop and wait for more than 40 seconds. Well, if we show up the first 45 seconds, we can walk automatically. The next 70 seconds, well, let's see what the last, if we show up the first 30 seconds of it, we would have to wait the entire 40 seconds before we'd have to walk. So I think we want the 30 for the seconds that we'd have to wait for more than 40 seconds over the entire thing, which would be what, 115. So let's see, let's reduce that real quick. So take a 5 out would be a 6, take a 5 out would be the 20, what was it, 3? Okay, so this would be our probability. Now out of 40 times, we will multiply that by 40 real quick. And we're going to go ahead and break the old calculator out here real fast. So calculator. So we're going to take 6 divided by 23, which gives us that. Then we're going to take that times the 40. So we'd have to wait about 10.5 times, it looks like. So we'd have to wait approximately 10 times out of 40. That isn't actually too bad. Okay, regular geometry students would be into those problems this time. Alright, we're going to skip that example. We're going to go on to the spinner here. Use the spinner to find the probability of each event. The pointer landing on yellow. So all we're going to do is take that central angle, which is 140, over the 360, and we always want to reduce. I'm going to knock off the zeros. Take a 2 out would be 7 over 18. That's as far as that will go. So bada boom, bada bang, we're done with that. The pointer landing on blue or red. So I've got to add those two together, would be 112 over the 360, and we definitely want to reduce again. Let's just break the old handy dandy calculator out. I think we want to take 112. Let's divide that by 4 real quick, and we got 28 over, let's see, take a 4 out of that would be 90. And then we can take another 2 out real quick. Will be a 14 over 45. I think that's as far as it will go. And then that it will not be landing on green. So we want to either add all these up, which would be what, 200, 252 over the 360. And we definitely want to reduce on that. So that's, let's see, 252 divided by 2, I guess, to start would be 126. Let's go ahead and divide that by 4, which would be, what, 63 over 90. And then we can take a 3 out of that, so we'd have 21 over 30. And then we can take another 3 out of that, which would be 7 over 10. And there we are. So these probability questions go pretty quick. Let's come up with a secret word for the day. Secret word for the day, we're going to go elegant. Elegant would be the secret word for today. Alright, one last type of example here. We got find the probability that the point chosen at random on the inside of a rectangle is in each shape, round to the nearest hundredth. So let's do a couple of these. I don't know if we're going to do every single shape here. Let's see if it will land inside the circle. So we're going to go with the probability of it landing inside the circle. So we want the area of the circle over the area of the entire thing. The area of the entire thing would be what, 50 times 28. So it looks like 1400 will be our denominator. And on top, for the area of the circle, we're going to have what, 9 squared times pi. So that's going to be 81 times pi. So let's go to a handy dandy calculator and put 81 times 3.14 equals, so 254.34. And let's see, let's just go ahead and get a decimal form out of this. So let's divide that by the 1400. And we're going to come up with about, what, 18% or 0.18 or 18% of the time. Alright, let's figure out one more, maybe that it would land on the maybe the squares. So probability that it would land on the squares. Well, our denominator is still going to be that 1400. But now each one of the squares would be what? 10 times 10, which would 100. So this is 100, that's 100, so that would be 200. So let's cancel those zeros, so about 1/7 of the time. Or if you wanted to go decimal form, 1 divided by 7 would be about, what, 0.14, or about 14% of the time. Alright, we could go the trapezoid next. Would actually be about the last one. I guess we've got time to do that. Let's go ahead and erase these real quick. Alright, so the area of the denominator again, area of the trapezoid, would be 1400. And let's see, for the trapezoid, we're going to have the two bases that we add together, so 34 plus 16 times the height of the trapezoid, which would be the 18, and we're going to divide that all by 2. So we're going to cancel the 2 in with the 18 and make that 9. We're going to add these together, which would be 50. So we're going to multiply that real quick, which will drop the 0. 9 times 5 is 45, so that's 450. So we can cross off the zeros, and we're just going to go to the old calculator and punch 45 divided by 140, and that's going to give us about 32% of the time, or 0.32, which would be about 32%. Alright, that's how we do area probabilities. So right here would be the regular geometry students, and there's the up one, down ones, and here's the boxes. Good luck with that. Alright, this is Mr. Lane signing off from OHS High School. Have a wonderful day.